Electric field and potential. Electric field का कहबा electric field is a region of space surrounding a charge or a system of charges in which any other charges brought in experience a force. It is to be noted that electric field exists around a system of charges even if there is no charge to realize its effect. An electric field has two important characteristics. कोटा होची direction and होची magnitude. The direction of the electric field at a point is the direction of the force experienced by the positive charge placed at that point. Hence, electric field at that point near a positive charge is directed away from it, whereas it is directed towards a negative charge. Electric field direction positive to negative को जाइथाए. तापर electric field intensity or electric field strength. The quantitative measure of the strength of an electric field is known as electric field intensity. Electric field strength को electric field intensity को जाइथाए. Electric field intensity का कहबा ना electric field intensity at a point due to a charge or a configuration of charges is defined as the force experienced by a unit positive test charge placed at that point. So, E vector electric field intensity is equal to force F vector divided by unit positive test charge Q naught, where E vector electric field intensity, F vector force experienced by the positive test charge Q naught. Electric field intensity is a vector quantity. Electric field intensity टा गोटे होची vector quantity. Consequently, electric fields must be added vectorically. Electric field टा vector quantity होइथिबारु added होइथाय कि को प्रणाली रे vectorically प्रणाली रे. Its unit in SI system is Newton per coulomb. Newton per coulomb. In ESU, dyne per stat coulomb. Electric field intensity due to a point charge. Consider a point charge Q. Let Q naught be the test charge placed at a distance r from it as shown in the figure. Q गोटे point charge, Q naught होची गोटे test charge. केते दूरतार अछि Q ठारू ना r distance दूरतार अछि. In accordance with Coulomb's law, the force experienced by the test charge Q naught in free space is given by F vector is equal to Q bada Q into Q naught divided by 4 pi epsilon naught r square r cap, where r cap is the unit vector in the direction from Q to Q naught. By definition, the electric field intensity E vector due to a point charge Q at the position of a test charge Q naught is given by E vector is equal to force experienced by the unit positive test charge F vector divided by Q naught. 1 by 4 pi epsilon naught Q by r square r cap. The direction of the E vector electric field intensity is along the line joining the charge Q and Q naught pointing outward if Q is positive and inward if Q is negative. Electric field intensity due to a group of discrete charges. To find the electric field intensity due to a group of point charges q1, q2, Qn, we calculate electric field intensities due to individual charges u1 vector, u2 vector, un vector at the given point and add them vectorically. So E vector होइगला केते इलेक्ट्रिक फील्ड इंटेंसिटी बा टोटल इलेक्ट्रिक फील्ड इंटेंसिटी इज इक्वल टू इलेक्ट्रिक फील्ड इंटेंसिटी ड्यू टू q1 चार्ज प्लस इलेक्ट्रिक फील्ड इंटेंसिटी ड्यू टू q2 चार्ज तर कौन पहला ना E2 वेक्टर प्लस ENA वेक्टर 1/4 पाई एप्सिलॉन नॉट ब्रैकेट भीतर रहला q1 बाय कि r1 स्क्वायर इंटू r1 कैप प्लस q2 डिवाइडेड बाय r2 स्क्वायर इंटू r2 कैप प्लस प्लस qn डिवाइडेड बाय rn स्क्वायर rn कैप 1/4 पाई एप्सिलॉन नॉट समेशन भीतर लिखले समेशन ओवर k इज इक्वल टू 1 रू na q k divided by rk square into rk gap, where rk is the distance from the charge qk to the point charge, where electric field intensity to be calculated. Rk cap is the unit vector and its direction from kth charge to the point charge. Direction कोउट को जाए ना kth चार्ज रू पॉइंट चार्ज पर्यंत. इलेक्ट्रिक फील्ड इंटेंसिटी ड्यू टू ए कंटिन्यूअस चार्ज डिस्ट्रीब्यूशन लेट dq be an infinitesimally small element of a continuous charge distribution. Electric field intensity dE vector at a point due to the element of charge dq is dE vector. Small electric field intensity dE vector is equal to 1/4 pi epsilon naught into dq small charge divided by r square into r cap, where r is the distance from the element of the charge dq to the point where the electric field strength is to be calculated. Electric field strength कौन ना electric field intensity. R cap is the unit vector. The resultant field strength due to whole of the charge distribution is obtained by integration of the above equation. E vector bracket भीतर r vector is equal to integration over dE vector is equal to 1/4 pi epsilon naught integration of dq by r square into r cap. The integral of equation may be a line, surface or volume integral depending upon whether the charge distribution is a linear, surface or volume distribution respectively. ये जो इंटीग्रल रही से इंटीग्रलटा लाइन इंटीग्रल हो पारे, सरफेस इंटीग्रल हो पारे, ना वॉल्यूम इंटीग्रल हो पारे. डिपेंड का पर करची ना जदि जे चार्ज डिस्ट्रीब्यूशन टा लिनियर हेतिबो ताले लाइन हबो, तदी सेटा सरफेस डिस्ट्रीब्यूशन हेतिबो ताले सरफेस इंटीग्रल हबो, जदि वॉल्यूम डिस्ट्रीब्यूशन हेतिबो तार वॉल्यूम इंटीग्रल हबो. For a line by linear charge distribution, dq is equal to lambda into dLA. E vector is equal to 1/4 pi epsilon naught integration over lambda dq divided by r square into r cap, where lambda is the charge per unit length and a dLA is the length of a small element of the linear charge. Lambda होची कौन charge per unit length. Charge divided by unit length. dl ହେଉଛି କ'ଣ? Length of the small element of the linear charge. The integration over entire length LA of the line charge. For a surface charge distribution, dq is equal to sigma ds. E vector is equal to ହେଇଗଲା କେତେ? 1/4 pi epsilon naught integration over sigma dq divided by r square into r cap, where sigma is the surface charge density and ds is the small element of the surface area SA. Integration is over entire surface area SA over which charge is distributed uniformly. For a volume charge distribution, dq is equal to rho into d phi. E vector is equal to 1/4 pi epsilon naught rho integration over rho into d phi divided by r square into r cap, where rho is the volume charge density and d phi is the small volume element of the volume phi. Integration is over entire volume phi in which charge is distributed continuously. Lines of force. Lines of force हमें क्या कहबा? A line of force is an electric field is a curve so drawn that a tangent to it at any point gives the direction of the electric field at that point. A line of force is an electric field is a curve so drawn at that point it at any point gives the direction of the electric field at that point. Lines of force होची कौन? इलेक्ट्रिक फील्ड रे गोटे कर्व रे जदि हमें टेंजेंट ड्रॉन करिबा से टेंजेंट दर्शेब कौन? डायरेक्शन ऑफ द इलेक्ट्रिक फील्ड. इलेक्ट्रिक फील्ड रो डायरेक्शन को दर्शेब. Faraday introduced the concept of lines of force. Lines of force रो concept को Faraday introduce करथिले. Accordingly, an electric field can be represented graphically by a number of lines of force. These lines help us to compare qualitatively the strength of the electric field at different points and determine the direction of the electric field at various points. A electric lines of force कौन साहाଯ୍य करंची ना गोटे इलेक्ट्रिक फील्ड रा स्ट्रेंथ को क्वालिटेटिवली कंपेयर करिया पई कार स्ट्रेंथ अधिक कार स्ट्रेंथ को कम दर्शेवा पई आउ इलेक्ट्रिक फील्ड रा डायरेक्शन इलेक्ट्रिक फील्ड रा जे कोन स्थान रे जणाइबा पई इलेक्ट्रिक लाइन्स ऑफ फोर्स हमको साहाଯ୍य करता है. Thus they gives a picture of how electric by E vector electric field intensity varies in a given region of the space, shows electric lines of force. गोटे पॉजिटिव चार्ज पाई इलेक्ट्रिक लाइन्स ऑफ फोर्स आउटवर्ड बाहर सब जाउचंती. गोटे नेगेटिव चार्ज पाई गोटे नेगेटिव चार्ज आड़ को जाउचंती इनवर्ड जाउचंती टू इक्वल पॉजिटिव चार्ज पाई दीटा इक्वल पॉजिटिव चार्ज पाई एपरि हबो आ दीटा इक्वल आ ऑपोजिट चार्ज पाई पॉजिटिव रु नेगेटिव जिवो लाइन्स ऑफ फोर्स करा. Qualitative aspects can be associated with the lines of force by defining electric field strength at a point in terms of electric lines of force as follows. The magnitude of the electric field intensity at a point is proportional to the number of lines of force per unit area. Area being normal to the electric field in the neighborhood of the point. This clearly implies that in the region of the closely packed lines, the field is stronger than the field in the region where the lines of force are wide apart. जो इलेक्ट्रिक फील्ड रे इलेक्ट्रिक लाइन्स ऑफ फोर्स गुरा क्लोजली पैक हेई अधिक परिमाणर लाइन्स ऑफ फोर्स देबे सेटा अधिक स्ट्रांग आ जोटी लाइन्स ऑफ फोर्स मध्य रे अधिक डिस्टेंस रही थाए सेई इलेक्ट्रिक फील्ड होची कम स्ट्रांग बा वीक. Properties of electric lines of force. Lines of force are a purely imaginary geometrical construction aiding the visualization of the pattern of the variation of the electric field in space. Lines of force गुरा होचंदी imaginary lines जो गुड़ाक इलेक्ट्रिक फील्ड को गोटे स्पेस रे दर्शाया पाई व्यवहार करा जाइताय. Lines of force originate at a positive charge and are directed radially away. Lines of force are directed towards a negative charge. Lines of force कौन करंती गोटे पॉजिटिव चार्ज रु बाहरंती आ गोटे नेगेटिव चार्ज रे नेगेटिव चार्ज आड़ को जानती. Lines of force originate at a positive charge and terminate at a negative charge. गोटे lines of force टा गोटे पॉजिटिव चार्ज रु आरंभ होती आ गोटे नेगेटिव चार्ज रे शेष होती. Lines of force never cross each other, otherwise there will be two direction of the electric field at the point of intersection, which is not possible because the electric field is a single valued vector point function. Lines of force माने दी जन मध्य रे केबे क्रॉस करंती नहीं. जदि क्रॉस करिवे ताले गोटे इलेक्ट्रिक फील्ड मध्य रे इलेक्ट्रिक फील्ड रा डायरेक्शन दीटा दर्शेब जोटा कि पॉसिबल नुहे. Closer are the lines of force, stronger is the electric field, and farther apart are the lines of force, weaker is the electric field. For uniform electric field, lines of force are parallel and equidistant. The electric lines of force are माने क्लोज अछंती बा लागी लागी अछंती ताले इलेक्ट्रिक फील्डटा स्ट्रांग हबो. जदि दीटा इलेक्ट्रिक लाइन्स ऑफ फोर्स मध्य रे किछि डिस्टेंस रही जाउची ताले इलेक्ट्रिक फील्डटा वीक हबो. जदि इलेक्ट्रिक फील्ड लाइन्स ऑफ फोर्स माने पैरेलल रहउचंती आ इक्विडिस्टेंस माने दी जन मध्य रे समान दूरता देई अनेक गुड़िए इलेक्ट्रिक लाइन्स ऑफ फोर्स होउचंती ताले से इलेक्ट्रिक फील्डटा होची यूनिफॉर्म. Lines of force from a charged conductor originate or terminate normally to its surface. गोटे चार्ज्ड कंडक्टर रे लाइन्स ऑफ फोर्स गुरा ओरिजिनेट माने आरंभ होती बा टर्मिनेट शेष होती केमिति ना तार सरफेस को नॉर्मल बा लंब भाव ओरिजिनेट करती आ टर्मिनेट होती. इलेक्ट्रिक लाइन्स ऑफ फोर्स नेवर पास थ्रू ए कंडक्टर. इलेक्ट्रिक लाइन्स ऑफ फोर्स टा गोटे कंडक्टर रे केबे हेले पास करिवे नहीं. हेन्स इलेक्ट्रिक फील्ड इंटेंसिटी इनसाइड ए चार्ज्ड कंडक्टर इज 0. तेणु इलेक्ट्रिक फील्ड इंटेंसिटी गोटे चार्ज्ड कंडक्टर मध्य रे